Hello everyone. Today we are going to learn about orifice meter. What is orifice meter? So the basic definition of orifice meter is to determine the discharge coefficient of fluid flow and volumetric flow rate. What is the purpose of orifice plate? Orifice plates are commonly used in primary elements for flow measurement in pipelines based on the principle of measurement of differential pressure. This is created when an obstruction is placed in the fluid flow. So this is due to the increase in fluid velocity. Construction and design of orifice plate. The material for orifice is selected such a way that its sharp edge and surface are not deformed due to corrosion and erosion. This is a thin flat circular plate with a circular hole concentric to the pipe. Sometimes a drain or vent hole is provided where plates meet the pipe to avoid accumulation gas and air bubbles in the tube. A differential manometer is connected at both upstream and downstream side of the flow. It is mainly divided into four parts: inlet section, outlet section, orifice plate, flow conditioner. Inlet section. A linear segment extending from the device and acts as an end connection for the fluid flowing inside. Outlet section. Also a linear segment similar to the inlet section where the pressure of the gas and fluid discharge is determined. Orifice plate. Present between the outlet and inlet segments and used to generate a pressure drop which enables the measurement of the flow rate. Flow conditioner installed in the inlet section of the meter tube and is used to enhance the linear flow in the inlet section of the meter tube. The working of orifice meter is based on the principle of Bernoulli's equation, is that the sum of all the energies at a point 1 is equal to the sum of all energies at point 2, where P1 is the pressure energy, rho V1 square is the kinetic energy per unit volume, and rho GH1 is the potential energy per unit volume. It also should follow assumptions like ideal fluid, steady state flow, Newtonian fluid, incompressible fluid. So coming to the next one is the formula. Actual discharge of the orifice meter is given by Q at is equal to AR by T, where A is the cross-sectional area of the measuring tank, R rising water level, T time. Theoretical discharge of the orifice meter is given by QTH is equal to A1 into A2 by root over A1 square minus A2 square into root over 2GH, where A1 is the cross-sectional area of the diverging section, A2 is the cross-sectional area of the orifice meter, G is the acceleration due to gravity, H height difference between the manometric tubes. The discharge coefficient is given by CD is equal to Q actual by Q theoretical. So one should remember that the CD value should lie between 0.7 to 0.85. Types of orifice plates. The typical design of orifice plates are concentric orifice plate, eccentric orifice plate, segmental orifice plate, quadrant edge orifice plate. Concentric. It is the far most common and mostly used on processes, but not recommended for use on slurries or high corrosive process. Eccentric are used for liquids that contain gases or solids. Segmental orifice plate. This is used for the same type of services such as eccentric orifice plate. It has a hole which is a segment of circle. It is used with a fluid containing more solid particles in it. They are more expensive than the eccentric orifice. So the next one is the quadrant edge orifice plate. This type is used for flows of dense fluids such as crudes, slurries and viscous flow. Its edges are rounded to form a quarter circle. They are useful in the pipe have a low diameter less than 2 inches. The drain hole is provided or located at the bottom when the gases are measured to allow condensate to pass in order to prevent its building up at the orifice plate. Coming to the advantages, disadvantages and applications of orifice meter. Advantages of orifice meter are it can be used with differential pressure devices. It is available in many materials and it is well known and predictable characteristics. Although it has a very well advantages, there are some disadvantages too. It causes relatively high permanent pressure loss. It tends to clog. Therefore, its use is restricted in slurry application. Its accuracy depends upon the care taken during its installation. It is subjected to erosion, corrosion and scaling. Coming to the applications of orifice meter, it is used in refineries, natural gas industries, petrochemical plants, water treatment plants, oil filtration plants. So that's all about orifice meter. Thank you.